Welcome to linear correlation using the p-value method. The p-value method includes the following steps. Number 1, we're going to set up the hypothesis test. Number 2, we're going to calculate the test statistic. Number 3, we're going to calculate the p-value. Number 4, we're going to make a decision. And 5, write a statement. So the first step is the hypothesis test setup, very similar to the traditional method, where h sub o is going to be rho equals 0. So we're going to assume equality here. So we're going to assume that no linear correlation exists. Okay, remember rho is the population correlation coefficient R. H1 or HA is going to be rho does not equal to 0. So this is where some linear correlation will exist. Step number 2, we're going to calculate out the t-test statistic. The t-test statistic is calculated using the formula R, which is calculated using Statcrunch. Remember the correlation coefficient R, divided by the square root of 1 minus R squared divided by n minus 2. So remember R is that sample correlation coefficient. And we're going to go ahead and use our calculator's advanced features or Statcrunch or some other form of technology to calculate the t-test statistic, and then also the p-value. So we're going to use technology to calculate both the test statistic and the p-value. So the p-value in step number 3 is, since the alternative hypothesis, the population linear correlation coefficient is not equal to, it's a two-tailed test. And so remember when we talked about the test statistics, if you remember looking at the graph, okay, if it's a z distribution, it's a two-tailed test. Okay, so there you go. There's that. And this is the test statistic, the positive and negative values of those. And the p-value, remember, is the area under there. So if the p-value here is, that's how we determine the p-value. Statcrunch, though, automatically calculates it all for us. Okay. Next, on Statcrunch, we're going to enter the data into those columns. So let me just show you what it will kind of look like here. You enter the data into the first column and second column. And notice I just have 1, 2, 3 in the first column, 4, 5, 6 in the second column. I'll relabel the column header for the first column X and the second column header Y. Then I'm going to go to Stat, and now I'm going to go to Regression, and then choose Simple Linear. My X variable, I'm going to select the X column. My Y variable, I'm going to select the Y column. And basically, I'm going to leave everything the same here, perform the hypothesis test for the intercept and slope. Everything else is going to be the same. And all I'm going to do is hit compute. Here we go. On this page, you can tell here they have the parameter estimates. And they have a t-test and a p-value, so that the t-test for the p-value for the slope is what we would be looking for here. So, and then if you go to the right, you can see here that the line is perfectly fine. That's why the values were given the way they were. So that kind of gives you an indication of what Statcrunch will look like. So after using Statcrunch, we're going to have to reach a conclusion. And so if the p-value is less than or equal to the significance level, we can conclude there is linear correlation. Because remember, the p-value is less than or equal to the significance level, we're going to reject the null hypothesis. And if we reject the null hypothesis, that's saying that HO does not hold true, so HA says there is some linear correlation exists. Okay, so then our statement is going to be the same. So in our statement, it says the sample data, and we're going to either choose does or does not, based whether we've rejected or failed to reject the null, provide sufficient evidence to suggest that then we can say a positive or negative Or we can have to leave it out if there's no linear correlation exists between, and then state the two variable requirements at a certain significance level. So the p-value method works just as well as the traditional method. They will get the same results.